This video will cover notes pages 3-3 and 3-4. So we looked at the domain and range of discrete graphs. So that's when there were just a bunch of ordered pairs. Remember, domain is the X and range is the Y. So now we're going to have continuous graphs, the ones where you don't have to pick up your pencil. These ones make it a lot more difficult, all right? And if you look at this note down here, we usually write them as inequalities. We didn't do interval notation, so we will write them as inequalities when needed. When you look at your domain, since it's your X, you're going to scan your pencil from left to right to think about what numbers can I be doing on the X-axis or along the X, which is left and right. For the range, you're going to go down. I want you to start down. That makes it a little bit easier, and up to figure out where we're going up and down on the graph. Okay, so I'll probably say up and down, but we want to start down just because it's going to be easier to write your answer that way. So domain is X, which is left to right. Range is Y, which is down to up or bottom to top. One thing I want you to realize is or something to look at, is if you can have any number. So another thing to think about when you're doing these is, what can't X be? Is there anything that X isn't? Or what can't Y be? If there is nothing that it can't be, so it goes on forever and ever. So if we look at number 1, when I go to the left, I see an arrow. And as I go from left to right, I never stop moving my pencil from left to right. It just keeps going forever and ever and ever. So if it goes forever and ever in both directions, left and right, what we do is we call it all real numbers, meaning any number you can think of on the number line. That includes fractions, decimals, square roots, weird numbers. Every single number to the left and to the right, we could keep going forever and ever and ever. Instead of having to write all real numbers all the time, you can put an R with like a double line. So our domain for number 1 is all real numbers, which you can just put as that R with the double line, meaning we go left and right forever. Now the range, if you notice, I don't start until right here. So I have a minimum value. I do not go any lower than -2. But I keep going up forever and ever. No matter which direction I go, I keep going up forever and ever, but I never get lower than that. So the way we would write it is Y has to be greater than or equal to, since it's touching, -2. So let me erase all my marks here. You can see right there that it is touching the -2 spot. So that's why it's greater than or equal to. I did not go below -2. So our range is Y is greater than or equal to -2. Number 2, I don't start until right here on the left, and I go over to right here on the right. So there's a beginning and there's an end. If you look back at number 1, there's no beginning or end for our X values left and right. This one, we do have a beginning and an end. The furthest left we go is -3. So we write -3 less than or equal to X. The furthest right we go is 3. So this is our compound inequalities where X is in the middle. X is between -3 and +3. Now, hopefully you realize since it's a circle, that's going to be the exact same thing as the Y. So the lowest we go is -3, less than or equal to Y, less than or equal to +3. So if you have beginning and ending points, you're going to have a compound inequality like we have for these. If we look back at number 1, we just had a single inequality for Y because it went up forever and ever, but it didn't go down forever and ever. And then we had all real numbers for domain for number 1 because there was no stopping or starting from left to right. Number 3, again, arrow pointing to the left, all the way over, arrow pointing to the right. There is nothing that y couldn't, or that x couldn't be, because it goes on forever and ever. So that one again is all real numbers. Even though it doesn't show very many, the range is also all real numbers, because this one would keep going up all the way, that one would keep going down all the way. So if you actually could draw out what these lines would look like forever and ever and ever, they would touch every y value. So those are both all real numbers. Number 4, I notice I have arrows on the left and on the right. So when you have arrows on both the left and right, your domain is going to be all real numbers. It would keep going all the way left and all the way right. The other thing we notice is that both arrows are pointing down. So it's going to go down forever and ever. However, it has a top or a maximum value. So 1, 2, 3, 4, 5, y is less than or equal to 5. If you think about the y values on the graph, 5 is the highest you go, and then you would have any number below that. Again, we included it because the line does touch the y equals 5. Number 5, we have a shape. We have a beginning and an ending on both. So anytime you have a closed shape, you're going to have your compound inequality. Sometimes it's easier just to put your x in the middle and the y in the middle. You know both arrows have to point to the left, and then we're touching them, so you're going to have or equal to's on both of them. You can do that, or you can do them each separately. The furthest we go left is -1, and the furthest we go right is 5. So x is between -1 and 5. For the range, the lowest we go is -3, and the highest we go is +3. So y is between -3 and +3. Number 6, as you can see, we have an arrow going left and we have an arrow going right. We never stop. It keeps going forever and ever. So that's going to be all real numbers. We also have one going down and one going up. So our range is also all real numbers. Number 7, this one gets a little bit tricky when we get to the range, but for the domain, this pattern here that we see is going to keep going forever and ever. It never stops going left and right. So that one is going to stay all real numbers. If you have a repeating pattern like this, even though there are arrows on the end, those are purposely kind of in the middle because you really are not going to go past here or here. So even though there are arrows, those have to be drawn to show this is going to continue. But if you have a pattern like that, you are not going to go above or below where you're at. So your range will have an actual inequality to it. All right, it looks like we are down 1, 2, 3, less than or equal to y, less than or equal to +2. Number 8, both of our arrows are pointing right, but we don't have any pointing left. That's because we have a starting value at -1. So x has to be greater than or equal to -1. Starting at -1 going right means greater than or equal to. Since you have one arrow pointing down and one arrow pointing up, that means it's going to go on forever and ever. So your range is all real numbers. These should almost be the easiest ones, but they end up being the hardest ones. We only have a line going straight up and down. That means your x, the only x value you have is 2. So your domain is actually x equals 2. Every single ordered pair on that line has an x value of 2. Nothing else is possible. So it is possible to have an equal sign for your domain or range. If you have a straight up and down or straight across line, you're going to have an equal sign. Your range, you have an arrow going down and an arrow going up. It never stops, so all real numbers. So number 10, we should realize is just the opposite. We have an arrow left and we have an arrow right that never stops. So all real numbers for our domain. Our range, every single y value is -4. So y equals -4. For 11, this one we have to be really careful. These almost should be the easiest because we have a starting point and a stopping point. You just have to be careful because there's a closed circle and there's an open circle. So we go left 2, so -2, it's closed, so less than or equal to x. This one is open, so just a less than sign, and that is over 5. So again, we don't care up and down. Left to right is -2 to 5, but -2 has to be closed, so you have an or equal to, and 5 is open, so you have a strictly less than sign. Your range, the highest it goes, or sorry, let's start with the lowest you go is -2. Since it's open, it's less than y. The highest you go is 1, and it touches the line, so or equal to. Number 12, the different dots don't matter other than you want to find your farthest left and your farthest right. That would be -4, less than or equal to because it's closed, x less than or equal to 5. For the range, we want to find our lowest and our highest. Find your lowest and your highest. That would be -3 less than or equal to y less than or equal to 5. For 13, we're going as far as we can left, but we stop at right 2. So x would be less than 2. Since it's an open circle, it needs to have just a less than sign. The range, our arrow's going down, but we start at 0. So y needs to be less than 0. And for 14, we have a starting point, but we don't have a stopping point for our domain. So x has to be greater than or equal to, because it's closed, -2. Same thing with the y. We have a starting point, but not a stopping point because it's going up the whole time. Y is greater than or equal to -4.